Welcome to Pica, the breakthrough assembly process from Matrix. With Pica, parallel integrated chip assembly, die are transferred directly from the silicon wafer to the antenna substrate. We accomplished this revolutionary parallel assembly approach by replacing the standard green tape used by the semiconductor industry to scribe the wafer into individual die with a wafer plate. The active area of the wafer plate is the same size as the silicon wafer. Holes are drilled through the wafer plate that are aligned with the center of each die on the wafer. Grooves are patterned in the surface of the wafer plate that match the streets between the die. An adhesive is applied to the wafer plate to hold the wafer during the standard scribing process. The wafer is aligned to the wafer plate with alignment marks, attached, and then scribed.
The next part of the Pica process involves the pin plate. The pin plate is designed to accommodate various size antenna pitches. The pins are aligned and then punch the dies from the surface of the wafer plate directly and simultaneously onto the antenna substrate. Before any die punch occurs, a bed of nails or pin plate deposits UV anisotropic adhesive to the die landing sites of the antennas, which are then cured upon completion of the die attach process. The web then advances to the next web segment, ready to start the next process iteration. As you can see here, the prototype machine, as it dispenses adhesive, punches the die, and advances the web, all in one parallel integrated chip assembly process. The system also shows the ability to add more modules and expand your assembly throughput to millions per hour and even billions to trillions per year. The process for attaching chips to antennas on substrates has always been a gating factor to pricing inlays at very low costs. We do believe that our ability to overcome this obstacle will go a long way supporting the wide use of this technology. As many industry observers have forecasted for years, at last companies can make technology decisions based on real products, not promising technology.